So, if you're like me, you don't like writing a lot. I mean, I got into math because I didn't have to write paragraphs. And when the teacher told me to write a 5-page paper, I said, but I can do it in one. So, I'm getting a little tired of writing paragraphs in math class. Maybe you are too. I will say that if you're not and you like writing these paragraphs to explain yourself and to prove these things, by all means, keep doing it. I love when students write nice paragraph proofs. But I do want to show you another way that you can do a proof. So first, I'm going to write one more paragraph proof and then compare it with our new type of proof. So if you take a look at this one here, it looks like I have this quadrilateral. Vertices are C, A, R, and E. And I'm given that EC is congruent to AC. So let's mark that down. We'll mark EC congruent to AC. We're also given that ER is congruent to AR. Okay. And what I want to prove is that angle A is congruent to angle E. So I kind of want to show, let me get a different color going maybe. I want to show that this angle down here, angle A, and angle E are congruent. That's what I want to do. So what you might be thinking about first as you start off, you write like something about your givens. So maybe we'll write like, we are given that segments EC and AC are congruent, as are segments ER and AR. So that's a good starting point. We usually list our givens first. Now, let's keep going. What statement would we say next? Hey, if you saw that shared side, if you saw that this side here, CR was in both triangles, it's a shared side, so it's congruent to itself, that's great. So maybe we'll list something like, let's say, by a shared side, we'll say that CR is congruent to CR. Okay, I'm typing it out in words just because since I'm typing on the computer, it's easier for me to do that instead of writing the congruent symbol. So bear with me when I do that. So what do I have so far? I have one pair of sides congruent. I have a second pair of sides congruent. I have 3 pairs of sides congruent. I got my 3 pairs of parts congruent. So what I would then say is maybe by side, 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 I would say maybe the triangle ERC. You know what, I'll try it now. Let's see. I'll do a congruent symbol in a second. Congruent to, let's see if I want ERC, I got to go to triangle ARC. And then once I know the triangles are congruent, by CPCTC, I know that the other parts are congruent. So we'll say by CPCTC, remember CPCTC, corresponding parts of congruent triangles are congruent. I've thought about giving a test and just asking kids, here's your only question. What does CPCTC mean? Students are like, no, don't tell me that. Okay, so that's kind of like our proof. What I do want to just add in really quick is a couple of these little symbols. So we'll throw one of those there, and let's do another one, and we'll throw it up there. There we go. So here's a good paragraph proof. So what I want to compare this to is what I call a flowchart proof or flowchart reasoning. This is the same exact proof you just did. But I want to show you where the different parts of our sentences are broken down into the different boxes of the flowchart. If this is the first flowchart you've seen, a flowchart is basically something that is like a step, like a checklist, like a step of boxes that you have to follow in order. So what's meant by that is, in box number 1, I'm going to write one of my congruent statements, one of my true statements. And then below the box, I'm going to write why that statement is true. In this case, AR is congruent to ER because it was a given statement. We were told that was true. The same thing in box number 2, that EC is congruent to AC. That's another given statement. So after those two, we have to find something else that's true in the diagram. And this is where we're going to say that RC is congruent to itself, but because it's a shared side of the two triangles. So notice that what I have here in this little grouping is I have my 3 pairs of congruent parts. 1, 2, and 3. So once I have those 3 things, then those 3 together flow into the next conclusion I can make, which is that now the triangles are congruent. And why are the triangles congruent? We write that on the bottom. We call that side, side, side. And once the triangles are congruent, then we can go to our final statement, which is that angle E is congruent to angle A by CPCTC. So one thing that we're going to harp on a lot is the structure of these proofs. What I want you to notice is that it kind of looks like you have 1, 2, 3 things congruent. And then those 3 lead you into congruent triangles. And then once you have congruent triangles, then you do something else with them. This form is always found in a flowchart type of proof. You will always have 3 pairs of congruent parts that lead to congruent triangles, which lead to usually a CPCTC type of step. What's going to make it a little more challenging, as we'll go through in class, is there might be something before one of these. Maybe there's something to do after you do this. So there's a lot of different ways that this can morph into different things, but they all will have this type of structure to them. And when we get to class, we're going to build more on that. But as long as you can see where each of our true congruent statements lead into our triangle congruency, which leads into our parts congruent. If you can follow that and make the flowchart for it, then all is good.